My name is Pranav Deshmukh, and I am here to present the project me and my teammates have been working on. Our project is distance measurement using different sensors. Measuring distance is a basic need in modern technology. It is parking. It is used in parking systems, drones, robots, and self-driving cars. There are three main types of sensors used for this purpose: ultrasonic sensor, laser time of flight sensors, and lidar sensors. All of them work on the simple idea. They send out a wave, wait for it to bounce back, and use the time taken to calculate how far the object is. The basic formula is distance is equals to speed into time divided by 2. Since the wave goes forward and backward, uh, ultrasonic sensor. First, we will talk about ultrasonic sensors working principle. It sends high frequency sound waves about 40 kilohertz, which we can't hear. That it is exceeding our hearing at 20 kilohertz. These sound waves hit the object and bounce back to the sensors. By measuring the time it takes to for echo to return, the sensor finds the distance of the object. So the steps are simple. It sends the sound, it reflects back, the echo is received, and the distance is calculated. The usual range is between 2 centimeters to 4 centimeters, and one popular module is the HC SR04. So there are strengths and limitations for this ultrasonic sensor. The advantages is it is very cheap and easy to use, works even in complete darkness, and is great for short or medium distances. It also connects easily with microcontrollers like Arduino and ESP32. There are limitations, however. However, it is not perfect for like temperature or humidity can affect accuracy as it sends sound waves, and the velocity of sound depends on the temperature and humidity of the air. If the object has soft or angled surfaces, the sound we may not reflect properly, and the wind can also disturb the sound waves, causing the wrong readings. So we will now future applications of ultrasonic sensor. In the future, the ultrasonic sensor will be seen in many areas. For example, smart parking systems can use them to detect available spaces automatically. An IoT device that they can send data to the cloud for live monitoring. With AI algorithms, the sensor's noise can be reduced to make results more accurate. And of course, in robots and automation, the sensors help in obstacle detection and collision avoidance. Secondly, I would like to talk about laser sensors working principle. The second, instead of sound, it uses infrared light pulses. It sends a pulse of light which reflects back from the object, and the sensor measures how long that light took to return. Since the light travels extremely fast, this method is very precise. Accuracy is up to a few millimeters. Typical range is up to 2 meters, and the most popular is like VL53L0X. So there are also advantages and disadvantages of this sensor. The laser sensors can very accurately respond very quickly, and they are small enough to fit inside any compact devices. They are also not affected by sound or noise in the surroundings. But there are limitations. They have few drawbacks too. Like their range is shorter. Brighter sunlight can affect their readings. They use more power and they cost a bit more than ultrasonic sensors. Their future applications are as follows. In the drones, in drones and robotics, they help in obstacle detection and safe movement. In gesture detection, they make touchless control possible, like controlling devices by waving your hand. They are also used for depth mapping, where they work with cameras to make 3D models of objects. In future, the sensor will become smaller, faster, and more power efficient. And the last of the sensors we will be talking about today will be the LiDAR sensors working principle. The third and most advanced laser sensor is LiDAR, which stands for light detection and ranging. Unlike the previous ones, LiDAR doesn't just measure one point, it scans an entire environment using thousands of laser pulses. Each laser reflects off the surface, and then the system measures how long it took to come back. All these readings together create a detailed 3D map of the surroundings. That's why LiDAR is a very important and self for the self-driving cars and robotics. It can measure long distances around 15 to 100 meters, and common models are TF Mini and RP LiDAR. There are also advantages and disadvantages of the LiDAR sensor. The advantages are LiDAR gives very accurate and long range measurements. It can make complete 3D maps and work well both in light and dark condition. It is also reliable for industrial use, but there are limitations. It's quite expensive to use, uses a lot of power, and it is a bit bulky. Also, dust, fog, and rain can affect its performance. The future scope of LiDAR is in the future, LiDAR will be a big part of technology. It's already used in self-driving cars and real-time 3D television and self-navigation. Smart cities can use for traffic monitoring and urban planning. It is also used in environment surveying for mapping farms, forest, and land areas. Next generation LiDAR systems will become smaller, cheaper, and AI powered. In conclusion, all the three sensors, ultrasonic, laser, TOF, and LiDAR, are useful in different situations. Choosing the right one depending on how much accuracy, range, and working environment. Together, these sensors can make automation robotics more powerful and intelligent. From this point, my friend Sanket will take on, and he will explain you the we are performing the ultrasonic sensor. He will be explaining you how it is work, how it is how you can make it by your own using Arduino.
Hello everyone, my name is Sanket Gabhale. Today I will explain the circuit diagram of our ultrasonic distance measurement project. The circuit connects an HCSR04 ultrasonic sensor to an Arduino Uno board. The purpose of the circuit is to make the sensor and send sound waves, receive the reflection, and allow Arduino to calculate the distance. Every connection in the circuit is made carefully for a specific reason. So let's go through the each one in detail. The main components used in this circuit are Arduino Uno, which acts as the main controller or the brain of the project. HCSR04 ultrasonic sensor, which is used for sending and receiving sound waves. Breadboard, which is used to connect components without soldering. Jumper wires are used for making the connection between Arduino and sensor. USB cable or power supply to power the Arduino. The HCSR04 ultrasonic sensor has four pins: VCC, trigger, echo, and ground. Let's understand what each pin does and why it's connected where it is. VCC pin. The VCC pin of the sensor is connected to 5-volt pin or the Arduino. This pin provides power to the sensor so it can operate. The XR04 sensor requires a 5-volt supply to generate and detect ultrasonic waves. If we don't connect this pin, the sensor will not turn on and nothing else will work. In some simple words, the pin gives the sensor the energy it needs to function. The ground pin. The ground pin of the sensor is connected to the ground pin of the Arduino. This completes the electrical circuit and gives a common reference for current flow. If we don't connect ground, the circuit remains incomplete and the sensor will behave unpredictably or may not work at all. You can think of VCC and ground as the two wires that supply power. One gives voltage and one completes the path. The trigger pin. The trigger pin of the sensor is connected to digital pin of the Arduino, usually pin 9. This pin is used by Arduino to trigger the sensor, meaning it tells the sensor when to start measuring. When Arduino sends a short pulse to this pin, the sensor emits an ultrasonic sound wave. If the pin is not connected, the sensor will never know when to start, so it won't send any waves. Basically, the trigger pin works as the signal sender or activator. Echo pin. The echo pin of the sensor is connected to another digital pin of Arduino, usually pin 10. The pin is used to receive the echo signal after the sound wave bounces back from the object. The sensors keep the pin high for the amount of time it took for the sound to travel to the object and come back. Arduino reads the time to calculate how far the object is. If we don't connect this pin, the Arduino will not receive any data and we won't get any distance reading. So the echo pin is like the listener that waits for the reflected sound to return. Now let's see how the circuit works. When the power supply Arduino board is powered on, it provides 5-volt and ground to the sensor. The Arduino sends an small signal to trigger pin to make the sensor send an ultrasonic sound wave. The sensor transmitter sends an ultrasonic wave at frequency of around 40 kilohertz. When the wave hits an object, it bounces back towards the sensor. The reflected sound is received by sensor's receiver. and the echo pin sends a signal back to Arduino. The Arduino measures how long it took for the sound to go and come back. This time is later used to calculate the distance between the sensor and the object. Now I would like to hand over the explanation of code to Vanik.
So, hello everyone, my name is Vanik Goregaonkar, and now I would like to tell you how to run the code on your laptop. So, first you have to open your Arduino IDE, which you can install from the web. It is totally free. Paste the code which we have given you in the description. You can just copy that code and paste in the web. Now, open the tools, go to the port and select the port in which you have connected your Arduino. Now go to the board, select Arduino Uno and you are done. Now let me explain line by line that how the code really works. So first, the first line is that slash include new ping. So basically, this line new ping is a library which makes it easier to work with ultrasonic sensors. Normally, we would have to finally handle sending and receiving the sound pulse, but the new ping library simplifies everything. It takes care of timing and calculation internally, so we can directly get the distance in centimeter with one function. Coming to the next line of the code, that is slash define trick pin 9 slash define echo pin 10 and slash define max distance 400. These three lines define constant use in the programs. Trick pin 9, this pin of the Arduino is connected to the trigger pin of the ultrasonic sensor. Echo pin 10, this pin is connected to the echo pin of the sensor. Max distance 400, this sets the maximum distance the sensor will measure in centimeters. Like here it is 400 centimeter, so it will convert into 4 meters. The slash define statements basically tells the compiler to replace the name with its value before the program runs. It's like creating a shortcut in the program. Coming to the next line of the code, new ping sonar trick pin echo commas max distance. Here we create an object called as sonar from the new ping class. This line connects our sensor pins trigger and echo with the library internal function. Now, whenever we use the command sonar dot ping centimeter, the Arduino will automatically send a sound wave from the trigger pin, wait for it to bounce back to the echo pin, calculate the time and convert it into distance and further into centimeter. So this line sets up the communication between Arduino and the ultrasonic sensor. Coming to the next line, we have a void setup. Serial begins 9600. Serial printf ultrasonic sensor test new ping library. So the setup function runs once when the Arduino is powered or on reset. Serial dot being 9600. This starts the serial communication between the Arduino and your computer at the speed of 9600 bits per second. It's allowed the Arduino to send the data like distance reading to the serial monitor. Serial.println is basically the statement which is used to print a message on the serial monitor to let know the user that the sensor is started with testing. Coming to the next code, we have a loop, that is void loop delay 50 unsigned in distance equals to sonar.ping centimeter. Here basically in this loop the loop functions runs repeatedly. This is where the main works happen. Let's break it down line by line. So delay 50. This add a 50 milliseconds delay between each reading. That means that the sonar will take 20 readings per second. It is important because ultrasonic sensor needs a small pause after each reading to avoid interfaces between the signal. Next, unsigned in distance equals to sonar dot ping centimeter. This line is the core of the program. The function ping centimeter comes from the new ping library. Here, what it does internally. So basically, it does like it sends a short ultrasonic pulse from the trigger pin, wait for the echo to return to the echo pin, measure the total time taken from the wave to travel to the object and back, convert that time into centimeter using the formula that is distance equal to speed of the sound into time upon 2, which results into measured distance is stored into the variable which is called distance. Coming to the next line, which we have that this tray lines prints the measured distance to the serial monitor. The first line prints word distance. The second prints the numeric distance value. The last one prints centimeter and moves to the new line. So when you open the serial monitor, you will see something like this when updated every 50 milliseconds. So summary of the working is that the new ping library is used to easily control the ultrasonic sensor. The trigger pin sends a high frequency sound wave. The echo pin listens from the returning sound. The library measures how long it takes for a sound to travel. The distance is then converted or been calculated and shown into the serial monitor every 50 milliseconds. Okay, so now we will demonstrate you the hardware project. So now we are running the code. Uh, we go to the serial monitor and the code started to run. Keeping the object on 3 centimeter, we get the output as 3 centimeter. Now we kept the box on 9 centimeter. We get output of 9 centimeter. At the end we kept the box on 14 centimeter and we got the output of 14 centimeter. Thank you.